Alright, chemistry. We are back to it after a shorter break than before, I guess. Just one day in between this time. SAT day. Well, PSAT day. We left off talking about atomic structure and the atomic models, kind of where we ended up now. There were a few questions to talk about. They were in the review book. Pretty much all of those should have been straight out of these notes. If you have questions on those that we kind of didn't get to talk about during class, send me an email. I will be happy to kind of talk you through those. In the meantime, we kind of keep traveling forward. And our next topic here is ions. And ions are a bit different from atoms, obviously. They have to be different. They have a different name. So the deal with ions is that they are this much different from an atom. But being this much different from an atom is just enough to give you a new name. Atoms are interesting, or maybe not interesting, because they have no charge. So the number of protons equals the number of electrons. However, that will not always be the case. When you have an ion, this first bullet point is the definition of an ion. So when you have an atom that loses one or more electrons, then it acquires a net electrical charge. It gets a charge that it's not zero, basically. And at that point, we call it an ion. Right? Now, electrons have functionally zero mass. They have a mass of 0 atomic mass units. So adding and subtracting electrons has no effect on the mass. It also has no effect on the number of protons. Think back to our understanding of the atom. You have the nucleus and you have electrons out here. I can add or remove electrons from out here without influencing what's in the nucleus. In fact, it's kind of essential that we don't influence what's in the nucleus. In order for an ion to be an ion of a particular element, then the atomic number, or the number of protons, has to be the same for both the element and the ion. Because an atom's atomic number, or an element's atomic number, its number of protons, is what gives that element its identity. I'm going to try to zoom in to make my writing life easier, because I'm struggling right now. That's okay. So the ion, an ion of carbon, would have the same number of protons. It would still have six protons for carbon, but it would have a different number of electrons. You can tell when something is an ion when it has a charge as an exponent. You should notice exponents in like quotation marks. In chemistry, we call it a superscript. So if I zoom way in, right here, see this lithium +1. Up in that top corner, this +1 represents the charge of the ion, right? So the charge is written as what we call a superscript. Super like above, right? Script is just the text that you write. So superscript is above normal text. We'll also talk later about subscript, so something that's below. We'll get to it. But right now, talking about ions, they have the charge, that's superscript. An ion, if an ion has more electrons than it has protons, then it has a negative charge because electrons are negative. On the other hand, if you have an ion with more protons than electrons, then it has a positive charge. Right? I have a different version of this that I like. The charge of the ion, if you actually want to solve for it, take the number of protons and just subtract the number of electrons. And that will give you your charge. If the protons is a bigger number, it has a positive charge. If the electrons has a bigger number, it'll be a negative charge. Right. So if you have an ion with 11 protons and 10 electrons, then by that logic, 11 minus 10 is +1. It's a +1 charge. And it's an element of, or it's an ion of sodium. The reason it's an ion of sodium is because it has 11 protons, and sodium has 11 protons, so it must be sodium. All right. Next piece I want to do is a little bit of identification. And then y'all are going to do a little practice without me. But I'm going to go through these practice questions first, and then I'll ask you to do some on your own. Now, how many protons, neutrons, and electrons are in the following ions and atoms? Before I do this section, I actually want to answer this question down here. Is this an atom or an ion, and how do I know? I actually know this is an atom. The reason I know that is there's no charge in that top right corner. There's no superscript, there's no exponent. Right? It's an atom. Has no charge. All right. At this point, in order to identify the rest of this, I'm going to need a reference table. And I'm going to need to go all the way down to the periodic table. So let's take a look. Lithium. No, is it lithium? It is lithium. Li. Right. So Li, lithium, has an atomic number. All right, let's take a look at this. Lithium has an atomic number of 3. That tells me exactly the number of protons. The number of protons, therefore, is 3. Because it's an atom, in an atom, P equals E. The number of protons is equal to the number of electrons, so there are also 3 electrons. Now we need to find the number of neutrons. If you remember all the way back from page 12, I talked about this mass number up here. And I said that this mass number is the sum, it's the total, the addition, adding together, the number of protons and the number of neutrons. Now you might be like, Kalimbum, this is like a decimal place number? How do you have like not quite a whole? It's coming, right? The explanation for the reason behind the decimal places here is coming soon. But for right now, when you work with the atomic mass, and actually most times when we work with the atomic mass, what we're going to do is we're going to round this to the nearest whole number. So I'm going to rewrite this over here. I'm going to call it lithium, atomic number 3, atomic mass of 7. Now the atomic mass equals the number of protons plus the number of neutrons. And the atomic number is equal to just the number of protons, which means the number of neutrons is the atomic mass minus the atomic number. So in this case, I'll do 7 minus 3, and now we get 4 neutrons. This, by the way, always true. Again, I think I talked, 90% certain that I talked about that on page 12. Now, this was nice. It was an atom. There's nothing special. There's nothing weird about this. What I'd like to do is take a look at the top of page 16, and we have slightly different questions, slightly different symbols. Important thing to notice here is that we have charges, right? So let's deal with the first one. Well, the first one on this page, which is number 2. So calcium plus 2, is this an atom or an ion? This is an ion because it has a charge. Easy enough, right? I've answered 1 out of 4 things. Notice that the order of protons, electrons, and neutrons here has changed. It's not for any particularly like specific reason. Let's just make sure you're paying attention. So calcium, Ca, I need to look. What is... I happen to know, as I go the wrong way. Calcium's right here. Has a mass of 40, has an atomic number of 20. So, again, I'll rewrite it here. I have calcium, atomic number at 20, atomic mass of 40, which means the number of protons is 20. It means the number of neutrons is going to be 40 minus 20, which is also 20. In order to find the number of electrons, I have to be a little clever. I have to remember that the charge is the number of protons minus the number of electrons. I know that the charge is plus 2. The number of protons is 20. I'm looking for the number of electrons. It's going to shift over. That'll do. At this point, if I subtract 20 from both sides, oh my goodness, what is happening? Technical difficulties, y'all. There we go. At this point, like I said, if I subtract 20 from both sides, I get that negative 18 is the negative number of electrons, but negatives on both sides, so I can make them both positive. The number of electrons here is 18. Now, just to check myself, it has a positive charge. And I said before that if you have more protons than electrons, you should have a positive charge. Well, let's see. I have 20 protons, and I have only 18 electrons, so it should have a positive charge. It's plus 2. Another way that you can do this, perhaps you've keyed in all this already. Whatever the charge is, right? Whatever the charge is, do the opposite to the number of protons, and that will give you the number of electrons. So this charge is plus 2. So take the number of protons and minus 2. That's how many electrons there are. That'll work every time too. Whatever works for you. If you didn't follow that, then ignore the last 30 seconds of what I said. Let's take a look at this third example, the second one on this page. Br minus. Again, this is an ion because it has charge. Right? Bromine. This time I actually have to go this way. Ooh, not that far. Please stop. So here's bromine, right here. Atomic number 35. Atomic mass, which rounds to 80. So, I'll rewrite it over here, just so that we have it as a reference. Bromine, 35, and 80. The protons is 35. The neutron number is 45. 80 minus 35. The number of electrons. This one's a little funny, because if you look at bromine down there, you'll see it's just a minus sign. If you see only the number sign, right? If you only see a negative or you only see a positive, then there's a number that's implied. And the number that's implied is 1. So it's bromine with a minus 1 charge. If I did it the first way, I would see that the charge minus 1 is equal to 35. Just kidding. Minus the number of electrons, so negative 36 is the negative number of electrons, which means the number of electrons is 36. You can also take that number, right, that charge, and do the opposite to the number of protons. The charge is minus 1. So I take that, I flip it, make it plus 1, and I do that to the number of protons. The number of protons plus 1. That's 36. Again, this makes sense because there are more electrons than there are protons, so it has a negative charge. Alright. Now, in between now and E-Day, right, on your remote day, on your remote D-Day, however you want to kind of look at this, I'd like you to do something. And what I'd like you to do is here. I guess I should have it both. You guys are getting a little what's what of how this ends up being made. Alright. So we're going to finish the rest of page 16 on E-Day, And then F day, pencil it in, F day is a quiz. It'll be in person. Fully remote students, you will get the usual email in the morning, and I will expect that quiz by about 11 noon. I think I said noon. Whatever time I say in the email. Like I said, we'll finish these up. I'll do some of this with you, but the big thing that I'd like you to do is the top of page 18 here. Now, there is something kind of funny about the top of page 18, right? It was printed a little strangely. Ooh, runner. This goes with this information, this goes with this information, and this goes with this. Everything else is fairly straightforward, but I'd like you to do the top here. This part 1, right? Sorry about that. Probably heard the buzzing. I silenced my phone, right? I've gotten better. It wasn't actually ringing, but it was buzzing. I apologize. I'll silence it next time. This one here, right? This is practice of identifying elements on the periodic table, finding the number of protons, finding the atomic mass, finding the number of neutrons, find the number of electrons, right? Do this top part, right? These 6 examples here on the top of page 18. I will actually start with these examples next time around. All right? I've droned on a little too long. I've crossed the 15-minute threshold. I apologize for that. I will try to make the next video a smidge shorter, but it is going to be quiz review, so it might be about the same length. In any case, if you do have questions, please email me. Otherwise, I'll see you all next time. Take care, chemistry.